Chapter 2, Engineering and the Healthcare Delivery System, by Proctor P. Reed from the National Academy of Engineering, and W. Dale Compton, who was since passed on, but was former professor at Purdue University and a VP at research at Ford Motor Company. These two engineers make the case that engineering will play an important role in helping make healthcare safe, efficient, patient-centered, timely, and equitable. They go through 6 points. The first, engineering systems. They define systems as large numbers of entities that operate collectively to meet a set of objectives. You could think of telecommunications, trucking, engineering systems, manufacturing systems. But as they write, a well-defined, efficient operating system requires that the overall objectives be clearly understood by all elements of the system, that feedback loops be supported by good communication and controls, and that some entity be in charge of the system and responsible for ensuring that its performance meets its stated goals. The reason we seldom hear about a healthcare delivery system is that healthcare delivery was never designed as a system and does not operate as one. Rather, as David Lawrence wrote in the previous chapter, healthcare delivery as a whole is fragmented, disorganized, and unaccountably variable. They go into part 2, the quality of healthcare, and they quote the Institute of Medicine 2000 report that states, every year, more than 98,000 Americans die and more than 1 million patients are injured as a result of broken healthcare processes and system failures. The gulf between a rapidly advancing medical knowledge base and its application to patient care is growing. Little more than half of U.S. patients receive known best practices. Poor quality is costly. Lawrence estimates that 30 to 40 cents on every dollar spent on healthcare, more than $500 billion spent per year, is allocated to either overuse, underuse, misuse, duplication, system failure, unnecessary repetition, poor communication, and inefficiency. What principles should guide how the healthcare system is re-engineered? They suggest 6, which are the ones from the Institute of Medicine's 2001 paper. It should be safe, effective, patient-centered, timely, efficient, and equitable. And they define equitable as providing care that does not vary in quality because of a person's characteristics such as gender, ethnicity, geographic location, or socioeconomic status. Leading to the third component, discussing the system tools. The contributions of engineers to industries outside of healthcare is widespread. We see systems engineering, industrial engineering, operational research, human factors, financial engineering, risk analysis, materials, microelectrical system engineering. And when we adopt a systems approach, we view a methodology that seeks to ensure any change to part of the system will result in a significant improvement in total system performance. So ideally, in healthcare, we can develop systems analysis that will demonstrate how the system is performing, ideally alert us when it is going off track, and provide a model that can anticipate how the system will respond to proposed changes. What is the difficulty of doing this? Move to section 4, challenges. 3 of them are proposed. The first, lack of data. The challenge to creating systems currently is the lack of data. There is practically no operational performance data available. The information systems that we have do not provide it. So therefore, such data needs to be collected manually, an intervention performed, and then operational data recollected. This is a major barrier to implementing widespread changes. The second challenge, fragmentation. Healthcare is a cottage industry. I was excited to see that the authors refer to healthcare as a cottage industry. I've used this term myself and think it perfectly describes the state of healthcare today. When you look at the incredible variation in quality, the lack of operational excellence, the extremely high cost in delivery, really, healthcare is the same cottage industry that textile production was prior to the Industrial Revolution. And the authors go on to apply this term cottage industry to the 700,000 clinicians practicing in the United States, of which over 80% of them are working in groups of 10 or less. The third challenge is chronic care. 3/4 of American healthcare spending is on chronic conditions. Such conditions require integrated, longitudinal care, which is distributed over many providers, each with multiple functions and specialized knowledge that can be integrated over time. The current healthcare system does not provide this type of care. We move to section 5. What are the barriers to cooperation? Doctors and engineers don't really understand each other, and this isn't entirely unexpected. The two professions have been educated almost entirely separate from each other throughout university. They have different methodologies, different vocabularies, different approaches, and even ethical values and frameworks. Engineers, the authors propose, should focus first on short-term projects in healthcare on issues that everyone agrees needs fixing. For instance, how to improve the scheduling of appointments in a clinic with high no-show rates. As the engineers gain trust and demonstrate their utility within the healthcare system, they can then progress on to solving higher-level problems in the system. And finally, part 6, how can engineers and doctors learn progressively to work better together? The authors suggest that 30 to 50 multidisciplinary centers should be created throughout America, where it combines system engineering tools, information technologies, social science, cognitive science, business management knowledge. And in these centers, they can develop skills in the delivery of healthcare, to do basic research, to solve real problems, and to train others to do so. Ultimately, a systems approach to healthcare needs to be integrated into the curriculum of physicians, clinicians, engineers, management, and public health schools. This chapter is kind of a no-brainer at the start of a book written by the engineering faculty to suggest that there is value to engineering in healthcare. I certainly agree that we do need engineering in healthcare. And I think the important thing from this chapter is that engineers and clinicians need to learn how to work together. I have certainly seen examples of system engineers coming into processes and essentially mucking things up from a clinical perspective, where perhaps the recommendations on paper made sense, but they didn't reflect the realities of patient care or the standard workflows or thought process of clinicians. Conversely, I've seen many physicians go on to be in management roles where they really lack the systems perspective, the engineering perspective, and the management perspective to be able to think of the logistical decisions that need to be made in the operation of a healthcare system. So let's put our baggage behind us and see how we can work together to make healthcare delivery safe, efficient, patient-centered, timely, and equitable.